Hi, in this video we are going to see how we can tune our instruction to make our LLM model behave as we like. So using instruction tuning we can change the behavior of the output which LLMs gives out and also tune it to give output as expected. So starting with the import statement, we import all the required libraries and packages. Then comes the loading of dataset. Here we are using alpaca dataset and we are splitting it into training and testing. So this instruction tuned dataset has our dataset now, and then we iterate on the top 5 rows of this dataset and printing it out, and in the output we can see what kind of instructions we have. So give 3 tips of staying healthy, and input is empty, and output we see like there are few points which are mentioned. Then the next instruction is give 3 tips for healthy staying, and response again is like some points. Then we see next is what are three primary colors. Input is empty and output is like the instructions, the output of the instruction. So this is the alpaca dataset which was there already, and we see how it looks like. In the next cell, now we are creating 2 prompt templates. So as you can see, below is an instruction that describes a task paired with an input, and we provide instruction, input, and response will be created by the LLM. So that is like one template. Second template is again below is an instruction. We give the instruction, we don't give any input, and just the response. So why we are using input here? For example, if we want to calculate some let's say sum of 2 numbers, we can say like sum of 2 numbers here in the instruction, and in the input we can give those 2 numbers. So in that case this type of prompt template is required, and this is the second prompt template. Now what we are doing is we took the top m entries from the dataset. We are like iterating it, and if input is not there in the instruction in this dataset, if the input is empty, then fill it into this prompt template which is without input. Otherwise fill it in the template which is with input. So that is how we are creating a list of all the process data with input and output template. Now coming to the next line, so we are just printing one of the example of the process data. So input is like below is an instruction, write a response that appropriately completes the request, and give 3, and this is the instruction. And the output which we expect from the LLM is these kind of points: eat a balanced diet, exercise regularly, and get enough sleep. We can also then save this data into a JSON-L file so that we can use it later. Now what we are doing, we are using a tokenizer from the existing model which is Uthrea AI. And what is tokenizer? Basically all the dataset that we have, we can tokenize it into form of like numbers so that model can easily understand it. And also in the next line we are creating a model. We are just taking a pre-trained model and saving it into a variable. Now comes the inference part, which takes in the input text model, the tokenizer that we are using, max number of input tokens and max number of output tokens. So this is the input IDs, and we are encoding the text which we are getting in. So this is the text, and truncation equal to true. What does this mean? That we can truncate, for example, the length of one sequence of words is let's say 100. So if we use truncate true, so we can set like how many numbers of maximum elements do we need into one single sentence. So that is truncation true. If there are like more than a certain limit, it will be truncated. Max number of input tokens, so it won't take like input tokens more than this. So this is the parameter based on which the truncation will happen. Next comes the generate part. So in inference we have now the input IDs in terms of numbers because the code cannot understand the direct word, so it is converted into numbers. Then comes the generate part. So we are using so if we have like GPU device can be set to GPU, otherwise CPU. and then the generate part, it takes the input IDs that we have tokenized and the maximum length of output token, so that it does not exceed the output compared to this number. So once we have generated the new tokens out of the prompt, now we have to decode it. So now we are like converting those numbers into actual words using the decode part, and then we are stripping the prompt. So the output which we get is actually appended to the input prompt. So we need to remove that. So using this statement, we can remove that prompt, and then we are just returning the generated output. So this is the code for inference. So in the next line we see fine-tuning dataset path. So we are taking the same dataset path which we have prepared here, that was saved into the JSON-L file. We can also load it from the Hugging Face. So we are just loading the same dataset and then we are printing it. So this is the dataset. So each object in the dataset represents one row, and every row has all these columns: question, answer, input IDs, attention, and labels. In this case, input IDs and labels are exactly the same. Yes. So then what we are doing, that we are printing a test sample, how the actual sample should look like. We are printing that, and also we are giving the same test sample into the inference code that we have seen above to see how the output would look like. So let's say this is the test sample that we have printed, in which we can see there is like a question: can Lamini generate technical documentation or user manual for software projects? Answer is yes, it can generate. And we can see the input ID. So input IDs are basically the encoded text that we are giving to the model, and then labels also we can see. So we have just created this labels so that the Hugging Face library can understand the input model, so it takes labels as input. So that's the reason. So this is like the test sample, and the actual model should output the generated text in this form. This is like what is expected, but when we did like inference on this test sample, you can see like what kind of output we are getting, which is not correct. So basically can Lamini generate technical documentation, and it is giving this kind of output for this, which is not correct. Why is this so? Because the model that we are using here for inference, so let's see what was the model. Test sample, and this was the model. And where did we get this model from? We took this model. So this model was actually not fine-tuned on the instruction dataset that we have. It is just like a pre-trained model, and it is not fine-tuned on the dataset. So if we like fine-tune any model on our dataset, it will then start giving the appropriate output in the expected format. So basically instruction fine-tuning is basically we are changing the behavior of the model, how it outputs the dataset. Now what we are doing, now we are comparing it, the output of the old non-fine-tuned model with the fine-tuned model. So how we are doing that? First of all, we are getting one fine-tuned model from the uploaded model which is already present, Lamini docs fine-tune, and we are saving it into instruction model variable, and then we are doing inference again on the same test sample that we saw. This is the model and this is the tokenizer, and when we do inference, now you can see how we are getting the output. Lamini can generate technical documentation for user manual, and this is the expected behavior of the fine-tuned model. So basically instruction fine-tuning can basically make your LLM model to behave in a way in which you like expect the output from that model. So using instruction fine-tuning, we can achieve that.